Good morning all. Today we will discuss region filling operation. So region filling operation, it is used to fill the selected region of the object. To understand the region filling operation, let us discuss an example. So look at the example 1. In example 1, it represents in the image A, it represents the boundary of an object. And in image A, the boundary of an object, it is represented by these shaded pixels. And inside these shaded pixels, these white pixels represent the hollow region of this object A. So we have to fill this hollow region by using this region filling methodology, considering this is my structuring element. So look at the structuring element B. In the structuring element B, the center pixel it is shaded, and we have considered the 4 neighborhood pixels of this center pixel. So let us discuss the step-by-step procedure of region filling operation. So once again, this is the boundary of the object and this is the hollow region which we have to fill by using this structuring element B. So in the zeroth iteration, inside this hollow region, we have to choose a seed point. So randomly we can choose any point. For simplicity, I am choosing this as my seed point, that is for the zeroth iteration. So this seed point, we will name it as x0, and in image we will represent it with 0. So in 0th iteration, this seed point we will make it logic 1, that is we will make it shaded. Considering the shaded it is logic 1 and unshaded it is logic 0. So 0th iteration, we have choose our seed point, we name it as x0. In image we mark it as 0 and we have make it logic 1. Now for first iteration and onwards, we will use this mathematical equation xk is equals to xk minus 1 dilation with the structuring element B intersection with A complement. So for first iteration, we will substitute k equals to 1. So in this equation, if you substitute k equals to 1, this equation becomes x1 is equals to x0 dilation with B intersection with A complement. So at x0, we have to perform the dilation operation with the structuring element B. So this is the point x0. At x0, we will apply this structuring element for dilation operation. It means the center of this structuring element, we will keep it here and we will perform the logical OR operation. So if you perform the dilation operation, these 4 pixels which is earlier at logic 0, after performing the dilation operation, it becomes logic 1. Now this dilated result we have to compare with this A complement. So in order to prepare this A complement, simple methodology I have used. The shaded pixel in A, that is logic 1 in A, it becomes unshaded in A complement, that is logic 0 in A complement, and the unshaded portion or the unshaded pixel in input image A, that is the pixels which is at logic level 0 in the input image A, it becomes shaded pixels in A complement, that is converted into logic 1 in its A complement output. So if you mark this 0th point in A complement, this is the 0th point and these are the 4 dilation output point. Now look at the output of the dilation. After performing the dilation operation, all these pixels will become logic 1, and in A complement all these pixels are at logic 1. It means all of these 4 pixels satisfy the intersection conditions, and hence all of these 4 pixels will be the output of my first iteration. So let me mark all these pixels. So since these 4 pixels, it is the part of my first iteration. So all these 4 pixels, these are x1, and in image I will represent it with 1. So after completion of the first iteration, next we will go for our second iteration. For second iteration, in this equation, we will substitute k equals to 2. So in this equation, if you substitute k equals to 2, the equation becomes x2 is equals to x1 dilation with the structuring element B intersection with A complement. So at all these 4 points, at all these 4 x1 point, we have to perform the dilation operation with this structuring element B. So let us perform it one by one. So at this point, if you perform the dilation operation, this pixel, this pixel, this pixel, and this pixel will be the part of my dilated output. That is, these 4 pixels, it becomes logic 1 after performing the dilation operations. So if you observe, this pixel, this pixel, this pixel, and this pixel in A complement, you can observe these 3 pixels are at logic 1, but this is at logic 0. It means this pixel doesn't satisfy the intersection conditions. So this pixel will not be the part of my second iteration output. Since these 3 pixels satisfy the intersection condition, so these 3 pixels will be the part of my second iteration output. Again, this pixel we have already considered as the point of 0th iteration, so we will not mark it. We will mark these 2 pixels as the output of my second iteration. So let me mark these pixels also. So since these 2 are the output of my second iteration, so I will write it here 2 and 2, and both of these pixels are the part of my second iteration output, and both of these are x2 point. Next, in the similar manner, if you repeat the operation at this pixel, and at this pixel if we perform the dilation operation, these 4 will be the part of my dilated output. And if you compare these 4 points in my A complement, so this is that seed point 1, and we have to compare this position, this composition, this position, and this position. Again, among these 4 positions, this pixel doesn't satisfy the intersection condition. So this pixel will not be the part of my second iteration output. And among these 3 pixels, these 2 pixels we have already marked. So we will consider this as the output of my second iteration, and we will mark it as x2. Similarly, if you repeat the operation for this pixel, only this pixel will satisfy the intersection condition, and it is the part of my second iteration output. And if you repeat the operation for this pixel, only this pixel will satisfy the intersection condition, and this is the part of my second iteration output. So let me mark it as x2, and in image I will write it 2. So after finishing off the second iteration, it's time for our third iteration. So in third iteration, in this equation, I will substitute k equals to 3. So the equation becomes x3 is equals to x2 dilation with the structuring element B intersection with A complement. Now in third iteration, these x2 point, at these x2 point, we have to perform dilation followed by intersection operation. First, we will consider this pixel. First, we will consider this point. So at this point, if you perform the dilation operation, this, and this will be the part of my dilation operation. So we have to consider these 3 pixels. So among these 4 pixels, these 3 pixels becomes logic 1 after performing the dilation operation, and in A complement these are at logic level 1, and hence these 3 pixels satisfy the intersection condition. So all these 3 pixels will be the part of my third iteration output. Let me mark these pixels. Since these are the part of my third iteration output x3, so in image I will represent them with 3. What about this dilation result? This dilation result, it is at logic 1. It is already at logic 1, and if you compare in A complement also, so it is also at logic 1. Since we have already marked it at 1, so we will not change. So we will not change it. Next, we will move on to this seed point 2. At this seed point 2, if you perform the dilation operation, this pixel, this pixel, this pixel, and this pixel will be the part of my dilated output. At seed point 2, if you perform the dilation operation, this would be the part of my dilated output. Among these 4 points, let us consider this pixel. So among these 4 points, if you compare this pixel will not be the part of my intersection output. So the remaining 3 pixels, we have already marked, and if you check in the A complement, these 3 pixels are at logic level 1. Since we have already marked, so we will not change. So it won't make any change. Now if you repeat this operation at this point, you will find there would not be any change after performing the dilation operation followed by the intersection operation. Similarly, at this point, and at this point, it won't make any change. So after completion of the third iteration, next we will perform the fourth iteration. At fourth iteration, in this equation, we will substitute k equals to 4. So the equation becomes x3 dilation with the structuring element B intersection with A complement. So at each point of x3 we have to perform the dilation operation followed by the intersection operation. First examine for this pixel. If you perform the dilation operation and the dilated result, if you compare with this pixel, will satisfy the intersection condition. Similarly, at this pixel, if you perform the dilation operation followed by the intersection operation, only this pixel will satisfy the intersection condition. And at this pixel, if you perform the dilation operation followed by the intersection operation, there won't be any change. So only these two pixels will be the part of my fourth iteration. So I will name it as 4 and it is also at 4. After completion of the fourth iteration, next if you perform the fifth iteration, that is in this equation in place of k we will substitute 5. So the equation becomes x4 dilation with the structuring element b intersection with the a complement. So if you perform the dilation operation at this point followed by the intersection operation, only this pixel will satisfy the intersection condition. And if you perform the dilation operation followed by the intersection operation at this point, it won't make any change. So after completion of the fifth iteration, only this pixel will be the part of my fifth iteration output, and in image I mark it as 5. After completion of the fifth iteration, it's time for the sixth iteration. And if you perform the sixth iteration, in this equation in place of k I will substitute 6. So x6 is equals to x5 intersection with the structuring element b. Sorry, x5 dilation with the structuring element b intersection with ac. So at x5, if you perform the dilation operation followed by the intersection operation, only one pixel will satisfy the intersection condition, that is this pixel, and hence this pixel will be the part of my sixth iteration output. After completion of the sixth iteration, if you perform the seventh iteration, the equation becomes x7 is equals to x6. In this equation in place of k I will substitute 7. So it becomes x6 dilation with the structuring element b intersection with a complement. So in seventh iteration, if you perform the dilation operation at this point, you will find no additional pixel will be added in the seventh iteration. That is, the result of seventh iteration and sixth iteration are same, and this is the point of, and this is called as the point of convergence. And at point of convergence, we have to stop our region filling algorithm. So now here I have summarized my region filling operation. This is the complement of the image A. This is the output of my 0th iteration. This is the output of my first iteration, second iteration, third iteration, fourth iteration, fifth iteration, and sixth iteration. After sixth iteration, when I performed the seventh iteration, I found the output of seventh iteration and the output of sixth iteration are same, and hence I stop my region filling operation at seventh iteration. And these are the algorithm which I have followed in region filling operation. In region filling operation, in the 0th operation, we have to consider the initial seed point x0, any point in the hollow region, and we have marked it as x0. Next, we have considered the structuring element b, and after considering the structuring element b, we have performed this repetitive operation, and for each iteration we have increment the value of k by 1, and we perform this mathematical operation, that is x of k is equals to f of k minus 1 dilation with the structuring element b, and this dilated result we have performed the intersection with a complement, and this result we have to store. And after each iteration, we have to compare this condition whether the result of my current iteration is it equal to the output of my previous iteration, and if this condition is reached, we have to stop our region filling operation. If this condition it is not reached, We have to repeat the operation from step 4 to step 6 till we reach the condition, that is the point of convergence. And after reaching the point of convergence, our region filling operation is over. Thank you.